Unit 7B, probability, the not rule, and the and or multiplication rule. Not E is an event made up of all possible outcomes which are not included in E. So if this circle represents all the possible outcomes of an experiment, and these are E, then the rest would be not E. And what the not rule tells us is that the probability of E plus the probability of not E is always equal to 1. E and not E are called complementary events. So the probability of an event plus the probability of its complement always add to 1. The not rule is also frequently written this way, where the probability of not E is equal to 1 minus the probability of E. So, for example, if the probability of F is 0.4, can you find the probability of the complement of F? Using the not rule, the probability of not F equals 1 minus the probability of F. But the probability of F is 0.4. 1 minus 0.4 is 0.6. So the probability of not F has to be 0.6. Pick an object from the bag, find the probability that it's red. Well, there are 5 objects in the bag. Of these 5, how many are red? 3. So the probability of picking red would be 3 out of 5. What's the probability of not red? Well, there are 2 ways to do this. Either count by counting or the formula. There are 5 objects in the bag. Let me count how many are not red. These 2 are not red, 2 out of 5. Or I could have done B with the not rule. The probability of not red is 1 minus the probability of red. 1 minus the probability of red, we did already, 3/5. So this is 5/5 minus 3/5. Subtract the numerators, 2/5. So we get the same answer either way. What's the probability of picking a circle? Well, again, there are 5 objects in the bag. I could count how many circles there are. 2, that would be 2 out of 5. For part D, the probability of not a circle, I could either count how many of the 5 objects are not circles, 1, 2, 3, or I could use the not rule. The not rule says the probability of not circle is 1 minus the probability of circle. 1 minus the probability of circle was 2/5. So that's 5/5 minus 2/5. Well, that's going to equal again 3/5. Conditional probability. In most books, conditional probability is written this way. The probability of A given B. I like to write it this way. The probability of A given B is the probability that A occurs given that we know B has already occurred. This is conditional probability. There's a condition there. Here's some examples. Pick an object from the bag. Find the probability that it's red given a circle has been picked. The way to do conditional probabilities is start with the given. Given a circle has been picked. So given, you're only talking about circles. Forget the rest. If you know a circle has been picked, what's the probability it's red? Well, there are two objects that are circles, and how many of those are red? 1 out of 2. What's the probability of picking a circle given a red object has been picked? Again, start with the given. Given a red object has been picked, you're only talking about the red objects, forget the rest. Of these red objects, of which there are 3, how many are circles? 1 out of 3. The probability of picking red, given you know a square has already been picked. So start with the given. Given you're only talking about squares. Forget the rest. There are 3 squares. What is the probability of picking a red one from those 3? Well, 2 out of 3 are red. Finally, what's the probability of picking blue given a square is picked? Start with the given. Given you're only talking about squares, what's the probability of picking a blue? If you're only talking about squares, there's only 1 blue among the 3 squares. A and B are independent if the occurrence or non-occurrence of one of the events has no effect upon the occurrence or non-occurrence of the other event. So, for example, A, toss a coin, then toss it again. Suppose you get a tail on the first toss and tail on the second toss. Are these 2 events independent? Does what happens on the first toss affect the outcome on the second toss? No. The coin has no memory. So these 2 events would be independent. If you take B, pick a card from a deck, and then replace it and pick a card again, if you pick ace on the first pick, does that have anything to do with picking ace on the second pick? Are these events independent? Well, when you pick the first time, what's the probability of getting an ace on the first pick? There are 52 cards in a poker deck or a bridge deck, and of those 52, 4 are aces. So the probability of picking an ace on the first pick is 4 out of 52. Now, if you do not replace the card, then you know after the card has been picked the first time, there are now only 51 cards left in the deck. And there may be either 3 or 4 aces. So now the probability of picking ace the second time is either going to be 3 out of 51 or 4 out of 51, depending on whether you picked an ace on the first pick. So what happened on the first pick does affect what happens on the second pick. So these 2 events, A on the first and A on the second, these are dependent, not independent. The multiplication rule is also known as the AND rule. Says, in general, and this always works, the probability of A and B is equal to the probability of A times the probability of B, given that A has already occurred. That always works. If A and B are independent, however, we have a simpler rule, which says the probability of A and B is the probability of A times the probability of B. Example, pick an object from the bag, find the probability that it's red and a circle. Well, you could just do this by logic or counting. There are 5 objects in the bag. How many of these would be red and a circle? Well, red and a circle means it's both. It has to be both red and a circle. And there's only 1 object out of 5 that's both red and circle. Or you could use the AND rule. The probability of red and circle is the probability of red times the probability of circle given red. What's the probability of picking red from this bag. There are 3 red ones out of 5 objects. Now, what's the probability of picking a circle given red was picked? Now, given red was picked means you're only talking about the red ones. Forget these. What's the probability of picking a circle now? Well, there is 1 circle out of the 3 red ones. The 3's cancel, and we still get 1/5. This time we're picking 2 objects from the bag without replacing them. What's the probability the first pick is a red circle and the second is a blue square? Well, here we're pretty much forced to use the multiplication rule. So it's the probability the first is a red circle, I'll abbreviate it that way, and the second is a blue square. This is the AND rule. So we're going to multiply. The probability the first is a red circle times the probability second is a blue square given the first is a red circle. What is the probability on the first pick you get a red circle? There are 5 objects in the bag. Of these 5 objects, only 1 is a red circle, so that would be 1/5. Now, for the second one, what's the probability of picking a blue square on the second pick, given you've picked a red circle on the first pick? Start with the given. Given you've picked a red circle. If you picked a red circle, we're picking without replacement. So that means the red circle is gone. The red circle is no longer in the bag. So now you're picking from 4 objects. What's the probability of picking a blue square now? There's only 1 blue square out of 4. So multiply now. The numerator is 1 and denominator is 20. So the probability is 1/20. Pick 2 objects from the bag without replacement. Find the probability both are blue. Well, we don't have a both rule, but both blue means the first pick is blue and the second pick is blue. So let me write it that way. The probability that the first pick is blue and the second pick is blue. Well, the AND rule says to multiply. The probability the first is blue times the probability the second is blue given the first is blue. Well, there are 5 objects in the bag on the first pick. How many are blue? 2 out of 5. Now start with the given. Given that the first pick is blue and we're not replacing it, we've lost one of these 2 blue objects. So let's say we lost the circle. We lost the blue object. So regardless of which blue object we lost, we're down to 4 objects to pick from on the second pick. And what would be the probability of picking a blue one now? How many blues are left? Only 1. 1 out of 4. So here we would multiply, or you could cancel, I guess. Cancel the 2 into 4 goes twice, and this is 1/10. So this probability is 1/10. That's the end of Unit 7B. See Unit 7C for the OR rule.